Hi everyone, it's Mrs. Meehan, and this is the first lesson in our unit for scientific inquiry. The objectives for this lesson, by the end, you should be able to explain how a scientific investigation is not exactly a linear process. You'll design a hypothetical experiment to test a common myth to demonstrate current understanding of experimental design. You will then explain your experimental design through a Flipgrid presentation and participate in peer review. Let's start with a do now. So examine the figure to the right. Why do you think this model is arranged the way that it is? Also, this model might remind you of the scientific method. How does it differ from what you may have learned about the scientific method in the past? Respond to the questions in the prompt. Okay, let's go over this. So here's the diagram again, but with some added annotations. So notice in the middle, we have questions. Questions are the most important part of the scientific process. Without questions, you wouldn't really have a reason to investigate anything. So the question is at the center of the scientific process. Now, this is also arranged in a way that you can really start anywhere. There's not a defined path. There are overall 9 steps, but you don't necessarily have to start in a certain order. You may not even progress in a certain order. You might have to go back depending on what happens throughout each of these steps. So you don't just move from 1 to 9 and that's it. You might have to go from 1 to 2, but then think, wait, what did I see again? Go back to 1. You'll end up with 3, 4, 5, but then you decide, wait, I need to research a little more before I am really happy with number 5 here. So there's a lot of overlap and interdependence between these steps. Everything on the outside supports this middle portion, the question. Now, if you did want to number these just for simplicity, based on what you've seen in the past with the scientific method, usually you'll see something like this that's a little more linear. So relating this diagram back to this one, here we have observation. So when you observe something, you're using your senses to better understand the natural world. The next step would be defining some type of problem, which would be a purpose or goal for your investigation. After that, you'll form a more specific study question. And then you would have to do some research here for number 4. You need to get the required background info or look at other related studies that might provide data that will help you with your investigation. For number 5, stating the expectations that would relate to the hypothesis. The definition of a hypothesis, you may have been told it's an educated guess. So yes, you've done some background information and observing, and now you have a pretty good idea of what you would expect to happen during your investigation. For number 6 is conducting the actual experiment and gathering data. So you're conducting the testing, you're observing again, you're measuring. You might have to research some more. So remember, there is some overlap here. For number 7, you would analyze the results. This would be looking at results in a data table, presenting that information, coming up with how to graph the information and looking for patterns. You would then conclude and reflect on your findings. Did your findings support or reject your initial hypothesis? Once that is all completed, scientists would communicate with the wider community. So they would go ahead and publish that scientific paper in a peer-reviewed journal. And then there are also science communicators out there that could help explain a study in terms that would be better understood by the public. The same thing with articles in scientific magazines or in news outlets. There's a lot of communication, whether or not it's entirely accurate, depending on the source of these findings. So this is the more linear diagram that you might be used to, but just keep in mind, even though it's showing you, okay, step 1, step 2, step 3, there's still a lot of overlap throughout. So just keep that in mind when you think about the process of science and what scientists are actually doing when they're conducting their investigations. So what you're going to do today is you're going to come up with a hypothetical investigation. So this lesson is called, or this project is called, An Apple a Day Keeps the Doctor Away, or Does It? So there will be a list of statements that you can choose on the next slide, and I will also post it to Google Classroom attached to the assignment. If you were to test the validity of this statement, what would you do? What would be your experiment to see whether that statement is true or not? You'll present your plan on Flipgrid. With Flipgrid, it will be visible to your peers. So once you post your plan, you will look at the plan of at least 2 peers and provide constructive feedback to them. What did they do well? What could be improved? You can respond directly to their post on Flipgrid with another video response. Please note, this is a first draft of a plan that will be revised in future lessons. So you will take another look at this plan after the peer review process and improve it as we move through the unit. For the list, you only have to pick one of these, and you're designing your experiment based on it. Notice there's also a free choice, so maybe you've heard some phrase or myth that you would like to investigate, and that's fine as well. Just make sure it's clear in your Flipgrid that that is the question that you are investigating. For this assignment, you will be graded based on a rubric, which you can find on Google Classroom. There are 3 main criteria that you'll be graded on for this assignment. The first is the clarity of your presentation. So your presentation is clear and concise. In terms of your explanation, maybe if it's very brief, that would be lower point value. The highest point value would be that you thoroughly describe your proposed experiment. So the effort is obvious is the next criteria. So the proposed plan shows thoughtfulness and is well explained. There's enough detail for a viewer to understand your hypothetical experiment. So again, your proposed plan would show considerable effort, assignment was turned in on time, and instructions were followed. That would be a higher point value. Use of prior knowledge. So student recalls and applies prior knowledge of the scientific method. So in your proposed plan, it's obvious that you're thinking back to what you've learned in the past from prior science courses and that you're using some of that prior knowledge in your plan.